Welcome back to our Cold Working 101 video series. Today we're going to talk about polishing your glass. We've covered different types of abrasives, how to use diamond tools, what different types of abrasives will do to your glass. We've shown you rough grinding from electroplated discs all the way to resin diamond discs through a pre-polish finish. So now we're going to talk about polishing your glass. Now, if you're working with stone or lapidary work, you can move to finer and finer diamonds, all the way up to 3,000, 8,000 grit, and get close to a polish, and it'll make the rock shine. This is not something you can do with glass. With glass, you're leaving off at best 600, 1,200 grit in a resin diamond, and you're still not going to get a polish from it. Going any further than that is just wasting your time. The only way to really polish your glass and get it back to clear glass is using cerium oxide. You may have heard about cerium, you may be using cerium. This is going to try and cover a lot of different information about using cerium oxide and what it is. So what is cerium oxide? Cerium oxide is a rare earth material. These are pieces on the periodic chart. It doesn't mean that they're rare or uncommon to come across, it's just the name of that set of materials on the periodic chart, be it cerium oxide, neodymium, praseodymium, any of those things are all considered rare earth materials. They tend to want to bind together with one another when you find them in nature. So cerium oxide is a naturally occurring element. It is mined directly from the earth. It is often mixed with a lot of other rare earth materials and a lot of other minerals and things that are in the earth itself. So cerium oxide needs to be processed. It needs to be separated from other minerals. It needs to be separated from other rare earth materials. Now remember, they bind together really strong, so it can be kind of difficult to separate other rare earth materials from cerium oxide. So you're going to see a couple of different things when you look at ceriums. The two major things you're looking at cerium oxide is, number one, the amount of actual cerium content in your cerium oxide. Number two is going to be the particle size of your cerium oxide. So number one, the actual cerium content of your cerium oxide can be a little bit tricky to figure out. A lot of places are going to list the actual rare earth content of the cerium. Now, as we talked about, that could be a lot of different rare earth materials, be it neodymium, praseodymium, maybe 5 or 6 other ones that could be mixed in with that cerium oxide. So if you see something that says 80 or 90% rare earth material, that may not always be cerium. You may only have 50 or 60% actual cerium oxide in that cerium. So it's important to know how much actual cerium content you have in your cerium oxide. The higher the cerium content, the deeper and brighter a polish you're going to get on your glass. The less cerium content, the more you're going to have a duller polish. It's still going to polish your glass. You're still going to get clear glass out of it. It just may not be as on a deeper micron level. The other part of cerium you want to think about is the particle size of your cerium. Now, cerium is a really small particle size typically. You're going to have something down from half a micron up to 3 or 4 microns. Those are all really small particle sizes. So it will have an abrasive quality on your glass as it's working on your glass, but it's not really an abrasive. The smaller the particle size you have in your cerium, the slower that cerium will work on your glass, but the deeper the polish will be on the glass. So if you're looking for something that's going to be a little bit faster, find something with a little bit larger of a particle size. It's going to polish things a little bit quicker for you. If you're looking for a deeper polish, a brighter polish, go for something that has a smaller particle size. It may be a little slower to polish, but you're going to get a much nicer polish out of it. It all depends on what you're trying to achieve with your cerium. Now, we talked about the particle size of the cerium and having a physical reaction with the glass. There is also a chemical reaction with the glass. When cerium heats up, it will actually chemically alter the surface of your glass and glaze it over, basically turning it back into a clear glass. Now, it does require heat to do this. Cerium is going to operate best when it's somewhere between 75 to 100 degrees. So when you're working with cerium oxide on your glass, you need to have some sort of media that will allow the cerium to have some friction between the cerium and your glass to generate that heat. Now, as we all know with glass, you don't want to generate too much heat. So you want to avoid saying, well, I'm going to heat up my water to 100 degrees and mix some cerium in there and put it onto the glass. Chances are you're going to end up cracking your glass. So you want to have water moving on your lap grinder or your tool or whatever you're using to grind and polish your glass with and that water will be warmed up by the media that is carrying the cerium oxide. And there's a couple of different ways that do that. Lots of different options when it comes to media for carrying your cerium oxide. So here we have some of the options that are available for carrying your cerium oxide or allowing your cerium to work with your glass. The most common options are something like a synthetic felt material or LP66 material. These don't do anything to your glass on their own. They are actually used with cerium oxide as a carrier. Now, these synthetic materials are made specifically to work with glass and polish your glass with cerium oxide. They are both what is called hydrophobic, so they will repel water, but they'll hold on to the cerium oxide. This gives these discs the ability to have a structurally sound system where if they do get soaked with water, they're not going to deform, they're not going to bulk up, they're going to stay nice and flat. They're also built so they're going to provide friction between that cerium and the glass, which we now know that you need. You need to have some heat, you need to have some friction for the cerium to actually work on the glass. These are very popular options for polishing your glass, be it on a flat grinder, a right angle grinder, or things like that. Another option is the natural wool felt. These are also very popular options for right angle grinders or for using as wheels on lathes. The thing that you have to remember with a natural wool felt though is it is going to absorb water. It is not going to be hydrophobic. It's not going to repel that water. So as you use it, it's going to absorb water, it's going to swell, it's going to bloat. So you have to be very, very careful when you're using natural wool felt materials. You have to spin them dry. Do not let them get soaked and leave them that way or they're going to deform. You're going to have to buy a new one. The nice thing about natural wool felt material using with cerium is it's not going to dry out as fast. You don't have to be as concerned with your water usage because this felt will stay wet. It's also not going to generate as much friction grab as the synthetic products will. Now they'll still create heat because natural wool is good for doing that. It's not going to get too hot and it's not going to create too much friction grab, so they're easier to work with. So natural wool felt is a great option in a number of cases. Just you have to be a little more careful about how you use it. Cerium can also be impregnated into a number of different products. 3M makes a really nice cerium impregnated Trizac material. If you're familiar with their Trizac material, it has tiny little pyramid shapes on the surface of the material. Typically, these are filled with aluminum oxide for abrasive grinding, but they also make this product that has cerium oxide in these tiny little pyramids that work really well. So you don't have to make a cerium slurry for your polishing. It's built into the disc. You just need to apply water, and the small pyramid shapes on the surface provide that friction grab. If you had this in your hands like I did, I can feel it grabbing my finger as I try and move across the surface of this pad. These little pyramids will give you friction between that cerium and the glass to provide that heat that you need for the cerium to activate and work on your glass. Pulper also makes a cerium impregnated material. So this is their extruded urethane material. You can find these in abrasive wheels that also contain aluminum oxide. This is one that contains cerium oxide. So this you can use to polish your glass with just water, no cerium slurry. Same sort of thing, this extruded urethane material, that structure gives you friction between the cerium and the glass, between the wheel and the glass, so it'll accomplish the polish for you with just water. So a lot of different ways you can use cerium. So since we've talked about cerium being mined from the earth, it's going to come in a powdered form. You can see several different ceriums that we carry here in bags on the table. So if we were to look at these bags, these are all 1 pound bags of cerium material. And you can see there's slightly different sizes of these bags. So cerium has a high specific gravity. The more cerium content you have, the denser that material will be, and thus if we're making 1 pound of it, the smaller the bag will be, the more cerium content there is. Now typically we will tell people the easiest way to mix your cerium oxide is to mix 1 part cerium to 2 parts water, be it in any kind of container you want to. We usually recommend a small squirt bottle, and that's really the best ratio for hand polishing of glass with your cerium. It's going to give you the right mixture, it's going to give you the right consistency that's going to work well on flat lap grinding. Now if you're working with something that's going to be vertical, say a felt wheel on a lathe or a felt belt on a belt sander, you're going to want to make that cerium a little bit thicker so when you paint it onto your glass, it's going to hang on to the glass a little bit longer when you're working on the felt wheel or the felt belt. So in that sense, you're going to want to make a mixture that's a little bit thicker than 1 part cerium, 2 parts water. may go 50-50, may go a little bit more. Now, the more cerium content your cerium has, the more it's going to want to stick to your glass. As we talked about, that cerium has a high specific gravity. The more actual cerium content you have, the more it's going to want to grab on and stick to your glass and polish a little bit better. It's a dense material. One thing to be aware of with cerium, with that high cerium content, the high density of it, is it's going to want to stick to everything. So if you have cracks and crevices in your glass, it's going to want to get into those cracks and crevices, and you cannot leave it in there. It's going to be virtually impossible to get it out of broken open bubble holes, small fissures, any little area the cerium can get into. It's going to get into, and it's going to stick there really well because it is very dense material. You need to wash that stuff off as quickly as possible while it is still wet. Do not let it dry on there. The same is true for your clothes. With a high density of material, if you get it onto your fabrics, it's going to be really difficult to wash it out of your clothes. That's why I always recommend trying to wear an apron if you're going to be doing polishing with cerium in any form. If you get it onto something, especially your clothing, it's going to be very difficult to get it out. White ceriums will come out a little bit better than orange ceriums. And you may be asking, well, what's the difference between the colored ceriums? There isn't any. Since it is a mined material, as we've discussed, the color is just basically where it is mined. Sometimes you'll get a whole lot of orange ceriums on the market. Other times it's a whole lot of white ceriums. Right now there's a lot of white ceriums on the market. It's just because of where it's mined. Colors will not make any difference beyond how badly they stain your clothing. The other thing to be aware of with cerium is a lot of people think that they have an allergic reaction to cerium. Now, we've talked about the density of cerium, how it wants to stick to things, how it wants to get into cracks and crevices. You're not really going to have an allergic reaction to cerium. What happens is the cerium is a desiccant. It will pull the moisture out of anything it gets in contact with. So if you get a lot of it on your skin, or especially if you have any splits in your skin or an open wound of any sort and cerium gets in there, it is going to drastically dry out those areas, which then is going to irritate your skin and you'll have a reaction to that extreme dryness. It's always good if you already have dry skin or if you have cracks in your skin or things like that, you might want to wear some gloves when you're polishing. I know it can be a little bit difficult to feel what you're doing with the glass when you're wearing gloves. And if you don't want to wear gloves, I do recommend as soon as you're done polishing, go wash your hands really well with a good moisturizing soap. Get that cerium off of there. Do not let it get into your skin or into cracks and crevices. It will annoy your skin. It will dry everything out. So just be aware of that and make it part of your housekeeping when you're polishing. Most ceriums that we carry are going to be suspension treated. That means when you put them in water, they're going to want to stay in suspension in the water. Now, a lot of people misinterpret that to think that once you mix a cerium, it's just going to stay mixed. That is not the case. The majority of cerium is going to separate from the water. It's just the way it is. You can see this cerium that I've mixed a while back. You can probably see on camera it's much lighter up here and very dark down here. This is a lot of the actual powdered cerium just sitting at the bottom of this squeeze bottle. If you let it sit for sometimes even 10 minutes or so, the cerium will separate and want to sink to the bottom. So every time you use your cerium, you're going to want to pick it up and shake it up to get all that cerium back into suspension. So suspension treating your cerium does not mean that it's always going to stay in suspension. It will separate. Don't panic. It's pretty typical. You just need to shake it back up and get it back in suspension. If you were to get a non-suspension treated cerium, it would literally separate almost immediately once you stop shaking it. So suspension treating is something that's going to keep it in suspension for you for a few minutes, which is all you need it for when you're applying it to your polishing. With cerium being a powder, you do have to mix it into a slurry. Now, we've talked about a good ratio being 1 part cerium to 2 parts water for hand lapping of polishing of glass. But where do we come up with that? Well, if you really want to dig into cerium consistency, you can use what's called a Baumé scale. And the Baumé scale is something that's going to give you an idea of how much cerium per water ratio you need for specific applications. For hand polishing of glass, you're typically somewhere around a 7% Baumé. The way you measure that, if you really want to get into the nuts and bolts of it, which is really not that necessary with art glass, you're going to see this a lot in the optics industry, but you'll need a graduated cylinder. You're going to want a 0 to 25 degree hydrometer. that will give you typically 1 to 1.2 specific gravity. So what a hydrometer does is it measures the specific gravity against water. So water will be a 1 on the hydrometer scale on specific gravity. Now hydrometers are typically calibrated for about 60 degrees. So if you're going to check your hydrometer, you'll want to fill a graduated cylinder with about 250 milliliters of water and get that water to about 60 degrees. If you put your hydrometer in there, it should float at 1. Now, if you're looking at trying to have a balme of about 7% on your cerium oxide, you're looking at a specific mixture of how much cerium per liter. And we'll put up a little gauge here to tell you how many grams per liter of cerium you want to mix for a 7% balme. What you would then do is mix your cerium for that liter, and you would pour 250 milliliters of that cerium into your graduated cylinder. Now at 7 degrees balme, you'll want about a 1.05 specific gravity, which would be about here on this hydrometer. So we've mixed this cerium before. I haven't tested this yet. I mixed it for the degree balme that we want of about 7 degrees. And we're going to test and see what it comes up with. So we're going to fill our graduated cylinder with our mixed cerium here. So you can see our graduated cylinder with about 250 milliliters of our mixed cerium. Now we'll take our hydrometer, and you want to make sure you can see your specific gravity scale here. We're going to put it in about as in the middle as we can and drop it into our cerium mixture. And you'll see we're pretty close. You can see right up here is our 1, which would have been our specific gravity of water. And we're almost exactly at 1.05 on our hydrometer. So my mixture of my cerium is spot on to where I want to be for the correct mixture for a 7-degree balme for hand lapping of glass. So if you really want to dig into getting your cerium mixtures exactly right for the process you're doing, you can work from a balme scale, get a hydrometer, mix and test your cerium every time. You need to make sure your cerium is about 60 degrees to get an accurate reading. You can go back and forth to try and get the correct ratio of your cerium. It just requires mixing a lot of cerium at one time, which is not all that necessary. When I got down to it and I actually mixed this correctly to get the correct balme for 7 degrees, it was almost exactly 1 part cerium to 2 parts water. So going by that rule of thumb, this is something you can do. It is not remotely necessary for most of your work. Now we're going to get to the nitty gritty. How do you actually use cerium on your flat lap to polish your glass? So you'll see I already have one of our LP66 pads on our 24-inch lap here. This is a brand new pad, so it's going to take a little bit longer to polish with it. Any brand new pad is going to need some charge time. Basically, the longer you use it, the more cerium you have on this pad over time, the less cerium you'll need and the faster it will polish. This is a brand new pad, so it's going to take a little bit longer for us to polish. And I'll show you what I would typically do with a brand new pad first to get it kind of charged up and ready for your polishing routine. Now we have our cerium that I've mixed here. We've already tested this with our balme scale, so we know it's a pretty good mixture. So we're going to shake that up to get it in suspension. I'm just going to apply some to the surface of our pad. Now typically what I would do when I first get a pad is mix a little bit of the cerium powder with a small amount of water and then smear it over the surface of the pad. Now this is pretty liquid right now. I'd make it a little thicker when the pad is new. And I would just do this. You're just going to get the cerium all over the pad to kind of charge it up and get it prepped for polishing your pieces. So I would do this, and then I would leave this pad overnight to dry. It'll let the structure of the pad grab onto a little bit of the cerium and make it a little bit easier to polish when you first start it. Now obviously I'm not going to wait till the next day here. We want to show you how to polish with this. So I'm going to go ahead and use this and give you some kind of pointers for use with the cerium. If you've watched our other episodes, you've seen how we work with diamond pads, our electroplated pads, our resin diamond pads, where the abrasive is locked into place on the pad and it's not a loose slurry. You'll remember this piece. It has been ground through electroplated, through resin pre-polish, and this is the surface we're going to polish. And typically, when we were using our diamond pads, we were using this very controlled movement back and forth on our pad. If you've watched our video on using slurry grinding versus diamond, you'll remember that diamonds we use a very controlled pattern, but when we were using the loose slurry, we have a little bit more of a random pattern to try and get the slurry to move underneath this a little bit better. That's the same kind of process we're going to use with polishing our pieces. Since cerium is going to be sort of a loose slurry material, we don't necessarily need to have a controlled pattern. I'm going to actually move all the way around our disc as I'm polishing. So I'm getting different directions of our LP pad on the surface of our glass as I move around. So it's constantly changing the direction of the slurry on the glass, and it will make this polish far faster than if I stayed in a more controlled orientation. The next thing to think about is water usage. Now, if you'll remember from our diamond videos, water usage is incredibly important. You're going to need more water with rougher grits, less and less water the finer you go. The same is going to be true with this. You already have water mixed in with your cerium to create your cerium slurry, so you already have a little bit of water. And we already know from our earlier discussion is that you need that water to be a little bit warmer. So you need to have friction between your cerium and the glass to warm up your water to between 75 to 100 degrees for the optimum polishing experience. So you don't want to flood this with water. All you're going to do is wash most of your cerium away, and you're not going to have enough water that stays on the pad to build up the heat that you need for the cerium to work. You need just enough water to keep this pad moist. Now, typically I run with a center water feed on my polishing because I'm going to be moving all the way around like this and up and down, and I don't want my external water feed in the way. To show you the amount of water that we're going to use with this, I am going to use my external water feed today instead of my center water feed. So let's turn on our machine and see how we're going to get this started. Now, I typically polish at about the same speed that I grind with. You can go a little bit slower with your polishing. That's perfectly fine. I would not suggest going too much faster because you're going to have centrifugal force pulling all your cerium off your wheel head too quickly. But I generally polish at about the same speed that I grind, and it works pretty well. Now you can already see now that our wheel is moving and I don't have anything else going, a lot of the cerium that I put onto our LP66 pad has already kind of flown off the pad due to centrifugal force. So the first thing I'm going to do is figure out my water usage for this pad. So you always want to make sure with any pad to get it wet first. So you have water going all the way to the end, from the middle to the edge, so you have a sheet of water on the pad. Then you can dial down your water usage. And like I said, we just need enough water on here to keep this pad moist. So this is just a steady drip. If I put my hand to the edge of my wheel, I can feel water coming off of this pad. So I have plenty of water. It's not running dry. That may actually be too fast of a drip. We're going to find out. So the first thing I want to do is take my cerium, and I'm just going to squirt some in the middle of my pad. And then I'm going to take my glass. You can see the pre-polished finish on that. And like I said, I'm going to move in the opposite direction of the way my wheel is turning. I'm going to go in and out, round and around. And you can see the surface of the pad is still kind of white with the cerium. If I pick up my piece, you can see that there's white cerium on the surface of the glass. That means I have plenty of cerium on this pad. I don't need to add a ton of cerium on here. If you do add a lot of cerium on your pad thinking you're going to polish faster, you're going to actually do the exact opposite of that. The more cerium you put on here, the more all those particles are going to gang together and become more like an oil, which means it's going to be really slick. And remember, we need friction to polish our glass. So if we put something on here that's going to behave like an oil and remove our friction, we're not going to polish. So all you're going to do is waste a lot of cerium, which is expensive, and not get your polish very fast. So it's important to remember less is more when it comes to trying to polish. So once you've gone through, you can see I'm not a lot of cerium on my pad anymore. So I'm going to add some more and go right back to polishing. The other important thing to remember with your polishing stage is it's going to be the longest stage that you have. It's going to take longer to polish your glass than any other step in the grinding process. A good rule of thumb that I typically tell people is if you add up all your steps from your rough grind all the way to your pre-polish, that's how long it's going to take you on the polish step. So if it were to take you 20 minutes on your piece to go from your rough grind all the way to your pre-polish, then you need to count on about 20 minutes on the polish pad to get your piece polished. It's a good rule of thumb. It typically stays true, and it gets you from being frustrated with the polishing step, knowing that it's going to take the longest of all of your steps. So you shouldn't get dismayed or frustrated when your pieces do not polish right away. They're going to take some time. Maintaining cerium on your pad, but not over maintaining your cerium, is crucial. Let's take a quick look at this and see what it looks like after that short time. So we've been polishing only for a few minutes on our polish pad, and you can already see it's becoming more and more translucent. And you may be able to see, it's kind of hard from the video, but you can see cloudiness in here. You know, it's still not completely clear, and I wouldn't expect it to. You know, this is probably going to be 15-20 minutes worth of polishing on here to get this back to clear glass. But even after just a few minutes, that's already pretty translucent compared to what it was before. So let's keep going on this. Now you'll remember that we talked about the differences between the different polishing media. This is an LP66 pad. There's also a synthetic felt pad or natural wool felt pad. I really like this LP66 pad. It maintains its form. It's got nice density to it, so it's not going to deform very quickly. It stays nice and flat. And it doesn't have nearly the friction grab that a synthetic felt does. So you can see I can barely hang on to this piece of glass here, and it's not ripping it out of my hands. A synthetic felt pad typically has a lot more friction grab to it, so it would be very difficult to do this or even hold it like this. It would tend to want to grab it and just throw it out. So I like these pads because they don't wear me out nearly as much because I'm not fighting the pad, but it's still providing me with enough friction for the polishing. So let's take a quick look at this. So I've been polishing this for about 5 minutes, not very long, 5-6 minutes. And you can see it's pretty clear. It's pretty nice polish. Now, if you look really close, which you won't be able to see probably on the camera, there are still lines in here from the pre-polish pad. So it is not really fully polished at all, but it's ridiculously close after only about 5 or 6 minutes. This is probably going to be a 15-minute polish time to get that fully polished, because that's about what my other steps were. But in about half that time, it's already nice and clear. So it goes relatively quickly, even on a brand new pad. If this were an older pad and already had some cerium on there, it would polish even faster. So it gives you an idea of how the polishing system works, how long it's going to take, the best way to mix your cerium to get the best results from your polishing without aggravating yourself to death. It's doable, it's easy, you just have to follow some certain steps and know how your cerium works.